Hello everyone, and welcome back to the videos on decimals. This is a technical skills video, and in this video I will be talking about addition and subtraction of decimals. And the algorithm is actually pretty easy. All we have to do is line up the decimal point and then add the digits or subtract them. And the act of lining up the decimal point lines up the place values, which ensures that we will be adding ones to ones and tens to tens, hundreds to hundreds, and so on. And on the fractional side as well, we will be adding tenths to tenths, hundredths to hundredths, and so on. Let's look at some examples. Problem number 1. We want to add 14.56 and 2.091. Now I'm going to line them up over here, and to line them up, I will make sure to line up the place values properly. All I have to do is line up the decimal points. And here's the picture that we have: 14.56 on top and 2.091 down here with the decimal point lined up. Now, of course, you could put 2.091 on top and 14.56 down. So long as the decimal points are lined up, it will give you the same sum. And it has to do with the fact that addition is commutative. You can switch the order in addition and you get the same total sum. Okay, so we have lined up the decimal point. And going back to the point I was trying to make, where I said that this lines up the place values, if you take a look, by lining up the decimal point, I've made sure that the ones are lined up, digits in the ones, the 4 and the 2 are lined up, and so we will be adding ones to ones. And on this side we will be adding, let's say here, we will be adding hundreds to hundreds. Okay, so now we draw a line, and then we start adding the digits in the same column. So of course there is a 0 here, there are no thousands in the top number, and so we can just pull the 1 down. Or you can think of it as 1 plus 0 being 1. And then we add the digits in the hundreds column. We have 9 hundredths in 2.091 and 6 hundredths in 14.56, and for a total of 15 hundredths. So we add 9 and 6, we put down the 5 and carry the 1. Now the act of carrying the 1 has to do with that special feature of decimals that I drew your attention to. The fact that each place value is 10 times larger than the one on its right and 10 times smaller than the one on its left. And therefore, because the size of a 1 here in the hundreds is 10 times smaller than the size of a 1 in the tenths, 10 of these make one of those. And therefore, when we add 9 and 6 and we get 15, we write the 5 down, but we take the 10 and turn it into one of these. And so we put the 5 down and carry the 1. And now we have 5 and 1, that's 5 tenths and 1 tenth, for a total of 6 tenths. When you get to the decimal point, carry it down. Then we add the ones, 4 ones and 2 ones. We get a total of 6 ones. And then 1, and again there is a 0 here, and you can just pull it down, or you can think of it as 1 plus 0, and we get 1. Okay, so the answer to problem number 1 is 16.651. Problem number 2. Now in this problem we have more than 2 numbers that we want to add, so it's like a chain addition, and we can deal with all 3 of them at the same time. You don't have to add 4.9 and 13.2 and then take the sum and add 0.41 to it. What we can do is we can line up the decimal point in all 3 numbers and then start adding the digits in the same column. So let's set it up over here. As you can see, I've lined up the decimal point in all of the 3 numbers. So 4.9 and then 13.2 and then 0.41. Now we'll start the addition in the hundredths. You always begin with the rightmost column, and we have 1 100th, and we'll put it down. Then in the tenths column we have 4 and 2 6, and 9 we have 15 of them. We put the 5 down and then we take the 10 and turn it into a 1, and then we put the 1 down, and now we have 4 and 3, 7, and don't forget to put the decimal point down, by the way. Now we have 4 and 3, 7, and then add 1 to get 8, and then we bring the 1 down. So 18.51 for this problem. Problem number 3. Now in this one of the numbers doesn't have a fractional side, so there is no decimal point and then followed by more digits. It's just a whole number, or a natural number if you like, 423. And you can think of the decimal point as being on the right end, because 423 should be on the whole side, and therefore if we put the decimal point in, it should appear here on the right end. In fact, you can do that with any kind of a number that's a natural number or an integer. Viewed as a decimal, you can always put a decimal point on its right end, and that again places the number on the whole side. Okay, so to line up the digits properly, we notice that there is a decimal point here where I'm pointing at right now, and therefore we line up the decimal points in that way. And now we start adding. 3 comes down, and then decimal point is moved down. Following this, we add the digits in the ones to get 12. We keep the 2, and we turn a group of 10 into 1 10 over here. So 2 and 1. And then we add the 10s, 2, 3, 4. We have 4 10s. And then we'll pull the 4 down. So 442.3. Okay, 3 more problems, and these are on subtraction. 4.51 minus 2.16. Let's set it up. Again, as usual, we line up the decimal point. And again, the reason is because this lines up the place values. So we will be subtracting tenths from tenths, and ones from ones, and let's say thousandths from thousandths. Okay, so here we have the numbers lined up. Decimal points are lined up, and now the ones are lined up, and the tenths are lined up, and the hundredths are lined up. Okay, we start the subtraction. Now here we cannot take 600ths from 100th. We cannot subtract 6 from 1, so we borrow from a tenth. You can think of this, if this was money, then the 4 would be the number of dollars that you have, the loonies. The 5 would be the number of dimes that you have. You have 5 dimes, interpreting the decimal digits 1 digit at a time. And then the 1 would be the number of pennies. So you have $4, 5 dimes, 4 loonies, 5 dimes, and 1 penny. And here you have 2 loonies, 1 dime, and 6 pennies. And of course we cannot take 6 pennies from 1 penny, so what we do is we take a dime and break it into 10 pennies. The idea for subtraction in general is similar. You take a 10 and break it into 10 hundredths. So a tenth and a hundredth. Again, going back to that relationship that one place value is 10 times larger than the one on its right side. So if I borrow 1 from here, I can pass on 10 to the place value on the right side. Okay, so we cross out the 5 and borrow 1. Turn that into 10 hundredths and add it to the 1 over here to get 11 hundredths. Okay, now we can subtract. 6 hundredths from 11 hundredths leaves 5. 1 tenth from 4 tenths leaves 3 tenths. Decimal point moves down. And 2 ones from 4 ones leaves 2 ones. Okay, now just to mention something though, that normally when we subtract, we don't really consciously think about the place values. So we just say something like 6 from 1 we cannot do, so let's borrow from the 5 and make this 11. That's the way we normally talk, and we say 5 becomes 4, 1 becomes 11. Now 6 from 11 is 5, 1 from 4 is 3. We don't say 6 hundredths from 11 hundredths leaves 5 hundredths, but just 6 from 11 leaves 5. And that's fine, because it sort of speeds up the process of talking and communicating. Although the understanding should be there, that you're really subtracting hundredths from hundredths, and tenths from tenths, and ones from ones. Okay, so the answer to this problem then is 2.35. And we move on to the next problem, which is 24.8 minus 1.47. Now we set this up, and actually I already have done that. So the decimal points line up again. Now here you have to be careful. You may not pull the 7 down. If the 7 was on top, you could do that. But if the 7 is down here, you cannot pull it down, because this 7 should be subtracted from something on the top, and in fact we have a 0 on the top. Now if the 7 was on top, and let me actually go back to one of the subtractions that we did. Yes, like here, where the digit is on top, the non-zero digit is on top, you can actually pull this down, because even if you put a 0 down here, then you say 0 from 3 leaves 3. However, if the 3 is down here, if the digit that we have that's not 0 is down here, then it should be subtracted from something from the top. And that's the problem that we had with this image. Okay, so here I have to subtract 7 from something on the top, and because there is nothing there, I can add a 0, and then we have 7 from 0, and we cannot do that, so we borrow from 8. That becomes a 7, and we pass on 10 to the next column. Now we can say 7 from 10. We start with the rightmost column. 7 from 10 leaves 3. 4 from 7 leaves 3 as well. We put the decimal point down. 1 from 4 leaves 3. And then you can think of, now because 2 is on top, you can actually pull it down. If you put a 0 down here, then you would say 0 from 2, 2. So 23.33 for this problem. Okay, one more subtraction problem. 96 minus 3.8. And what's special about this problem is that one of the numbers again doesn't have decimal digits. 96. But again, you can think of the decimal point as being on the right end of 96, and therefore we line the problem up like this. The decimal point is 96, in 96 is here, and we line the decimal points up. And now again we have to subtract 8 from something, and therefore we're going to add the decimal point, and then a 0, and then now we borrow from 6, and we pass on a 10 to the next column. Again, if this was money, you would be borrowing a loonie, and you would turn it into 10 dimes. Okay, so we borrow from 6, and we pass on 10 to the next column. Now starting with the rightmost column, 8 from 10 leaves 2. Decimal point comes down. 3 from 5 leaves 2. And then 9 being on top can be pulled down. And again, keep in mind that if you had a 0 here and you would do 0 from 9, you would get 9. So 92.2 for this problem. Okay, now one quick comment about chain addition subtraction of decimals. And if you're working by hand and there's a whole bunch of numbers, some of them are being added, some of them are being subtracted, then it pays off if you add your gains, add your losses, and then subtract the losses from the gains. Everything that I'm saying here about chain addition subtraction of decimals is identical to what we had with natural numbers and integers. There is absolutely nothing new here. And I'm going to illustrate the point through an example. 14.7 plus 5.8 minus 7.9 plus 13.8 minus 5.7. And in this problem, we are adding some of the numbers and subtracting others. And keep in mind, as before, every addition and subtraction goes with the term that follows. So we are adding 5.8, we are subtracting 7.9, we are adding 13.8, and we are subtracting 5.7. You can think of additions as gains and subtractions as losses. And sometimes people call additions sources, and subtractions, they're called sinks. Alright, so here we have a gain of 5.8 followed by a loss of 7.9, followed by a gain of 13.8, followed by a loss of 5.7. And what we can do is we can add all of our gains, beginning with 14.7, which being positive would be a gain, as you can think of it as 0 plus 14.7, and therefore we have a gain of 14.7, gain of 5.8, gain of 13.8. We're going to add those and then subtract the sum total of all the losses. That would be the sum of 7.9 and 5.7. If you're working with a calculator on a calculator, then of course you would go from left to right and punch in the numbers as you see them. But if you're working by hand, then this approach where we add all of our gains and then subtract the sum of the two losses here, 7.9 and 5.7, is easier because it involves fewer subtractions. Addition is much easier than subtraction, and while going from left to right here would require that I subtract twice, once when I get to 7.9 and then again subtract when I get to 5.7. With this approach, even if you have 10 subtractions, it turns into 1 because you will have a chain addition that would be the sum of all the gains, followed by a chain addition again that would represent the sum of all the losses, and then you would do the subtraction once. You would subtract the sum of the losses from the sum of the gains. You would subtract total loss from total gain. And again, this involves only one subtraction, and in that way it's more efficient. Okay everyone, that brings us to the end of this video. Now let's just finish it before I go. So 34.3 for the total gain and 13.6 for the total loss. And this leaves us with an answer of 20.7 for the problem. Okay everyone, thank you very much for watching the video, and I'll see you in the next video in which I will be talking about multiplication and division of decimals. And for now I will be gone in 3, 2, and 1.